we'll go ahead and get started. I know some other folks are finishing up, getting their lunches, no problem. Feel free to get up and go back. You won't offend us. There are sign-in sheets in the back, so if anybody needs AIA course credit, please sign the sheets back there, and we'll make sure we pass that along to AIA, and you'll get your credits for today's course. So today's course is Understanding Site Grading, so hopefully that's why everybody is here today. A little bit more in depth is how it impacts your bottom line. So we're going to talk a little bit about financials and some considerations, but ultimately we want to give you how we look at it as civil engineers and understand how the numbers come into play and how maybe there's some things we can do to help get some budget out of the earthwork and bring it to the building, which is the main focus of any project. So today my name is John Laboon. We're with Langan Engineering. We're a civil engineering firm, mostly offices up and down the East Coast and West Coast. Offices here in DC. We're headquartered outside New York City in Parsippany, New Jersey. And we have offices in Los Angeles, and Miami, Tampa, up and down the coast, Portland. Also joined with me today is Josh Newsom from our Arlington office, a project manager with our site civil group. Just a quick disclaimer from AIA, just saying, hey, you're here for an AIA course. It's approved for education credits, but not necessarily endorsed by them, what we discussed today. And this is, again, just another slide for housekeeping from AIA that it is approved for credits, and that we will take your name, your numbers, give it to AIA, and they will then reach out to you with your credits. So today's topics for site grading is just a quick introduction to site grading. Then we're going to cover a lot of the basics. We're going to spend a little bit of time on this, understanding what drives a site grading design, what factors and things we consider when we're looking at it. Then we'll get into a little bit of the methodologies of how you do site grading, from just basic hand sketches to some basic CAD modeling, and then get into some really advanced 3D virtual modeling that we're doing nowadays. And then again, 3D visualization and model coordination. How the site civil software is starting to speak with Revit now, and we're starting to make a lot of gains in that world. I'm sure if you ever try to bring a civil 3D grading file into the Revit file, they don't match very well. There's a lot of issues there, but it is getting better, and Autodesk has a solution, hopefully, on the near future. So just diving into the basics, and please feel free to jump in if you have questions. We love it. We like having an engaged discussion. We're happy to give you our thoughts on it, but it makes it that much better when you guys weigh in. So please feel free to jump in. So here's just some general basic guidelines that we use as civil engineers when we're looking at a site. Basically, when you're looking at a site and you're looking at the topography of it, and you're in that 0 to 2% range from slope across the site, that's the sweet spot. That's where we want to be. That makes a project work really well. We're not spending a lot of time moving dirt and putting in mitigation measures to overcome some topographic challenges. When you get to the 2 to 8% range, again, it's still fairly good. You'll start to notice. You'll notice that there's some gentle hills. You might have an approach up to your building from your parking lot. You're going to start to see a topographic change. When you get into the 8 to 16%, then you're definitely going to start noticing it. And you will have some pretty aggressive driveway slopes and things like that, maybe some slope landscape gardens to make up grades. But again, still fairly a workable site, but it definitely comes into play, and it's going to impact your building and the site layout. As soon as you go over that 16% threshold and you're getting into that 24% range, it's possible. It's not the most ideal situation for a site. You're definitely looking at retaining walls. You're definitely starting to spend some money out in the site world to make that site work for a building. And then over 24%, we just generally don't recommend it. Anything's possible, right? But it does come with a premium. So just something to keep in mind. So visualizing grades, we like to show the slope because we talked about grades in a whole bunch of different terms. Sometimes we say percentages, or you'll hear 3/1, or 45-degree angle. So what does all that mean? You can see by this slide, and I know it's kind of hard to see in the back, but basically the blue line at the very bottom is a 2% slope. That's normally what we try to achieve when we're doing site grading, because one is ADA compliant, so we don't have to worry about our routes and how people are traveling. It's just, we're good to go. And that's really a 50-to-1 slope. So you can tell it's pretty flat, right? 50 to 1, 2%. Really good slope to hit when we're doing site design. On the extreme opposite, a 1 to 1 would be a 45-degree angle, very steep. Normally, you're not doing that in the site world. We would have to do walls. And then a 3 to 1, normally we say 33%. That's basically about as steep as we can go with site grading before we're looking to some type of turf reinforcement or some type of stabilization method. So that's this line right here. That's basically the slope you can imagine the ground would travel. So it's good to understand what these lines mean. It's good to actually draw it out and understand when you're talking the slope so you can kind of visualize that. And what you don't want to happen is something like this, where you have a driveway that's just unusable, right? Just someone not paying attention to the slopes, they put it on the plans, it gets built. So other than maybe my son enjoying sledding down that in the winter, not a very useful driveway. So it all begins with the data, right? Site grading is really interacting with what we're building, a proposed project, whether it's a building, a structure, and the existing topography around that project. It's touching it, it's interacting with it, it's gauging it. So you have to have good data. You need to know what you're looking at. So just the different levels, GIS and record drawings is where we start. Perfectly acceptable for schematic design, illustrative sketches. It's great and it's cheap. It's usually free. We normally can get it free. It's a great starting spot. And then when you're starting to get into your design development, you need to take that next step forward, and you're normally doing a site topographic survey. That could be a field crew that goes out and you see them out there with their stakes and they're shooting it with a total station, or it could be an aerial survey, drones nowadays, where it flies it and it hits the ground with basically laser beams, and it gives you a really good model of the topography of the grading. And then when you really need to shoot for the stars and have just the best of the best, laser scanning, and that's the picture you see here. And laser scan is the new hot technology. We do a lot of it out of our office. It's one of our up-and-coming services that we've really seen a lot of traction go the last 5 years, especially from the architectural industry. And that basically we are able to set up our scanners. It can scan anything, and you get a point cloud, millions of points. It's showing you everything. It's showing you the curbs, the steps, the ramps, light poles, guide rails, the whole 9 yards. And you can really start to visualize how your project would blend with that existing environment around it. So cost-wise, it's the same thing, right? Good, good, basically free, maybe a small investment. A site survey is very reasonable. It gets you normally where you need to go. And then if you really need that detailed model, we can do laser scanning, but obviously it comes with a little bit higher of a price tag. This is just a model so just to back up, this is what the scanner sees. You see a point cloud, millions of little points. And then what we can do with that information is build a Revit model off of it and then give that over to the architect group to use. So this is just a Revit model of the Kennedy Center that we did not too long ago right here in DC. As you can see, this would have looked like the previous slide. It would look like that, but we can build it in Revit, hand it over, and then the architects can use that to blend together. Just some more guidelines, and we won't go too much in every single line item here, but the important thing to point out is on the very far right, it says preferred grade. You see that 2%. Again, I mentioned earlier, that's just a really good grade. It's a sweet spot for us. It gives really good site drainage, so you're going to avoid the nuisance ponding. And again, it's ADA compliant in all directions, so you're not worrying about accessible routes and things like that. But generally speaking, for streets, if you're looking at a street grade, you want to stay under 10% longitudinal slope. You don't want to go too steeper than that. You certainly can, and we do a lot, but it comes with considerations that you need to think about, especially in an area like this where we get snow and ice. To go down to another popular one would be parking lot design. We have to keep that at 5%. That helps keep doors opening at appropriate speed, and they don't fly away from you when you open it if you're parked on a steep hill. Again, it's just good for navigating for people walking, pedestrians, and things like that, right? Sidewalks, you can, 3% is nice for a run-in slope. 10% is getting a little bit steep, but still acceptable. So I know this presentation will be made available to you. So again, I won't go through all these, but you can take a look. It gives you that range of min and max slope. And minimum grade, although we didn't really spend a lot of time talking about. It's important too, because at the end of the day, we want to make sure our site's drained well. Nobody wants standing stormwater. We don't want ice to accumulate, things like that. So we do want to have a good slope on it as well. So there are minimum grades to consider.
A lot of sidewalks have to be infested.
Yeah, no, exactly. Yep.
Less than 5%.
Yeah, for sure. So
There you go.
getting into some of the ADA requirements. You guys are very familiar with this. You've been dealing with it probably a lot longer than we have in the site world as far as ADA compliance inside the building. But on the outside, it really does have a drastic impact on your grades. And also has an impact on your building first floor elevation and how that ties and communicates and engages the street front. And long story short, lots of ADA requirements. We won't go into them now, but just to understand that when we're looking at it from a site perspective, we're going to start saying, how do we get, an accessible route from the public right away to the doorstep? And does that influence the building? Do we want switchback ramps? Can we get a nice route without handrails? Things like that. So it does have a pretty impactful play when we're doing site grade and setting first floor elevations.
Can I ask you a question?
Sure.
So those are all like minimums or maximums. Is it your company policy to design it less than that
Absolutely.
for construction? Tolerance?
Absolutely. Yeah, to give some tolerance, because I mean, I'm sure you're probably familiar, right? But there's people out there that make a business off of finding non-ADA compliant things and lawsuits. Right, yeah. So they're out there with levels and stuff. So when we design it as civil engineers, a curb ramp, if you go up to 8.33%, we'll never design that in our plans. We'll go down to like 7.5%, 7% to have a little tolerance in there for constructability. I would say the same thing would be probably applicable in the architectural world with like railing clearances, right? Have like an extra ½ inch in there or something. And then obviously driveway and roadways. Again, we're just hitting on the basics, what influences grading. Obviously the approach of a driveway or a roadway to or around your site. Site triangles, which you see down here in the yellow, also have an impact on grading, making sure that cars can see over hills. It's not too steep, not too I guess flat's okay, but you don't want to have a berm or too big of a depression or even visual barriers when you're going around corners. As far as the arcs and the dips, we also need to make sure that when we're grading, that a car or a truck can go over that slope and not bottom out, right? So we do that. We have a lot of cool models and software where we can make sure that the grades are being accounted for appropriately. So grading to, this is, now you're really starting to get into the main drivers, in my opinion, of grading, and it's really drainage design and stormwater management. The aesthetics come into play, the earthwork come into play, ADA comes into play, all these things that we were talking about. But at the end of the day, as civil engineers, what we keep in the back of our mind all the time is making sure we're not going to flood a brand new building, right? That it's going to be protected. And especially with today's weather, you're seeing a lot more extreme events. It's all over the news. It's, nothing new. It's something that's even more important to us now than it was 15, 20 years ago. So when we're looking at grading designs, we're really considering what we call and think about as overland relief. So if you have water that's ponding, and your drains on the surface are filled with water, your pipes are filled with water, how's that water going to sheet flow around the buildings and around the site? Make sure it doesn't end up in the front door or the lobby. So a lot of time and energy goes into that. And you can see here we do a lot of overland relief. This would be called a spillway, and sometimes we have channels, sometimes it's just vegetated landscaping. But avoid things like this where you have a steep hill that comes back to the back of a building, you have standing water. All those things have a really big impact on grading design. And here's one that most people don't think about, but existing utilities could also impact your grading and really start to influence your FFD of your building. So just to give you an example, if you have a storm pipe in the street out here, and we know that storm pipe is a certain depth, and we need to connect to it, and we need to provide a gravity line at a certain slope, you start to run the gravity line, that's what I'm talking about here on the bottom, you start to run the gravity line at a minimum slope, it's starting to set what that grade looks like as you go into your site further and further. So obviously we can always do a pump station, but that comes at a cost. So if we're trying to keep things cheap, efficient, and drain things by gravity, we need to understand where those utilities are, how deep they are, and how that might actually start to push the grade up on our site. And even actually start to set the FFE of the building. So something underground that's existing could also have a pretty big impact on your gradient strategies. We talked about drainage design, but stormwater, they go hand in hand. They are different, but obviously stormwater management facilities also have a large driver and impact to site gradient. A lot in this area, in the DC and the Mid-Atlantic area, you're looking more at facilities that are underground that you can see here. You'll see rainwater harvesting systems, cisterns a lot, because we don't have a lot of land. But if we were outside, say, out in Loudoun County, where we do have a lot of site available, you start to get into stormwater basins, things that are at the surface, much more cost effective and a lot cheaper to install, and schedule-wise are a lot faster as well. So that they have an advantage there, but you need a lot of site to do it. Okay, so I just wanted to touch on a balanced site. Has everybody heard that phrase before, balanced site? Right. The idea is that you have, the green dashed line would be your existing grade. Of course, this is exaggerated a little bit. The red would be your proposed grade, and the stuff above the red line is what you would be cutting. You'd be taking that dirt away in order to get your proposed grade. And below in the green here, this would be the area that we're filling, so we're putting dirt in there. So the idea when they say balanced site, and everybody wants one because it's the most cost-effective approach, is that you have the same amount of cut as you do fill. So whatever you're cutting, you can put right back in the hole, and you're not taking fill off-site, you're not bringing fill on-site, right? Pretty simple concept. What we're here to tell you today is it's not always the best, and it's not always the cost-effective. And we would caution you to chase that too hard on your jobs. And the example here is the top is balanced. It's even 200 cubic yards of cut and fill. On the bottom, it's not balanced. So we have a lot more cut and we have a lot less fill. There's an added earthwork cost. However, you can see your building expanded quite drastically. So even though you're paying a little bit more for earthwork and we don't have a balanced site, the economics behind the project is going to make a lot more sense because we're getting a lot more buildings available. So just something to keep in mind. This is obviously a very simplified example, but it's just something that a balanced site is great, but it's not always the best solution. Yes.
Is there a loss factor that's a good rule of thumb to assume when you do try to build a balance that you're not going to be able to build it back to the same volume?
I think the next slide covers exactly that. Yeah, great question. There you go. So we'll just jump right on in. So cut fill, swell factors. So the idea here is that, when you have a cubic yard of cut or a cubic yard of native fill or native soil that's in the ground, not touched. When you scoop it out and you put it in the truck, it's not going to be as compacted as tight. It's going to sort of, it's going to loosen up, it's going to come undone. And you really need, instead of having 1 cubic yard of in the ground, you're going to need 1.25 cubic yards of space for your trucks to carry that away. So what that means is you need more trucks to carry it away. It's not just that that 1 cubic yard you scoop out, 1 cubic yard goes in the truck, that material expands as it gets dumped. On the same line of thought, when you put it in the ground and now you have your compactor, that same cubic yard goes down to 0.9 cubic yards. So if you scooped out 10 cubic yards, you're not going to have 10 cubic yards to put back in the ground. You're only going to have 9. You're going to have to buy 1 more cubic yard. So that's what we call basically shrink swell factors. And a lot of times this is more of an exercise for the contractor. So they know how to move material, but it does come into play when you need to buy material to fill, or you're shipping a lot of material off because it could have an increased truck costs. So other things that go as far as the grading is concerned in earthwork, right? Earthwork is really the movement of soil, the movement of material. They go hand in hand, obviously, with the grading strategy. But things like building foundations and basements, retaining walls, swimming pools, stormwater management facilities, large utility corridors, all these create a lot of earthwork, a lot of cut, a lot of digging, right? So we might want to find a grading strategy where we can reuse a lot of this cut on the site so we don't have to pay to haul it off. So that could impact your grading analysis and grading approach. Also, contamination, especially around here in DC. This isn't, unfortunately, not something we don't run into too often. But if soils are contaminated, normally when you cut them, you're not allowed to put them back in. Now, there are things where we can do environmental caps, and we come up to a agreement with the agencies of how to manage them on site. But generally speaking, if you have dirty soil, when you scoop it, it has to be taken off. So you're paying now to truck it off, and now you're paying to dispose of it. So it's an added cost and needs to be considered in your grading strategy. And some soils, they might not be contaminated, but you can't use them on site. You don't see a lot of that around here, but we do see it a lot. Our office here in Arlington does a fair amount of international projects all over. And a lot of the soils outside the states you run into fairly common are collapsible soils where when they get wet, they collapse on themselves. And expansive clays where when they get wet, they swell up, right? They expand. So these are soils that we don't want to use on our site. Once we scoop them, once we cut them, we want to take them off. So just some more earthwork considerations. All right, we're going to wrap up the design basics real fast and get into some of the methodologies, but just some other things just to hit on. We want to preserve the existing roadway grades, right? When we have a site that's against an existing roadway, which we always do, you can't change that roadway grade. So we have to make sure we're blending to it. We want to make sure we drain away from high use traffic areas and obviously build visibility of, or the building visibility of the main roads. As you're approaching down a road, what does our site look like? This particular site's perched way up on a hill. Maybe that's the look you're going for, maybe not. It just depends. It's very project specific. And then obviously functions and aesthetics. Always thinking about gate swings. How gate swings. Make sure that the grading's flat so it can swing. Door openings. We're always looking at vehicle turns, loading dock levels, maintenance, constructability. All these things go into our grading analysis and assessment and strategy for our project. So now I'm going to turn it over to Josh, and he's going to talk to you a little bit about the methodologies and how we actually go and execute a grading plan.
My name is Josh Newsom. I know John just threw a lot of information at you. Grading is really important. I feel like a lot of our RFIs are grading related, where you're talking about gates. Someone will design a gate but not think about how it swings open during snow or it's swinging open uphill. So grading is very important. The old-fashioned way of doing grading is method number one, grading by hand. You guys may have remembered this from back in the day. Basically, we just look at the contours, we visualize where the water is going to flow. We use our scale, and we sort of, using maybe 2-foot increments, figure out how the site's going to work. There you go. So basically, we identify the points, we draw lines between the points, and then we basically use that and we interpolate our contours. The modern method, as it's developed, it's even changed a lot in the past 5 years, has been using Civil 3D to create surfaces. Basically, we're not really drawing the contour lines, we're drawing feature lines representing top of wall, bottom wall, base of curb, the building elevation. And then as we build this 3D model, the Civil 3D will then generate the finished product, which is the contour lines. But it basically goes a lot more just into drawing 2-foot or 1-foot contour lines. So what is the grading model? Picture on your right is something that was created. You can see that you have some terrace walls, you have some dry valves. Looks like there's a lot of slope on this site and basically required a lot of detailed site grading so that the buildings would tie into the existing streets. Once again, it's sort of the same methodology, but basically we're defining, this is very general, but we're defining the elevation of these various points, and the software is drawing triangles, a 10 file. Everything is sort of generated in this model. So working with Civil 3D. So this might be an existing condition, and then we'll model that into Civil 3D, and then we will also model the proposed condition. One thing to think about is when we have a basement, we want to subtract out that area. John talked about underground storm management vaults, pools, utility trenching. If we're really doing a true comparison, we want to also maybe subtract out those values, or at least let the contractor and the architect know what our assumptions are, so we're not just comparing two surfaces, we're really subtracting out all the values we need to. From these two surfaces, using Civil 3D, we will then do a cut fill analysis, an earthwork analysis, and we'll sort of identify which areas are cut, which areas are fill, which areas are blended pretty well. It's very iterative, as you can imagine. And from this, we will work with the architect and the client to see if we can reduce fill, reduce cut, and really try to keep everything as blended as possible. So you can see in this model, the original one had more of a net volume, and we were able to reduce that. But this is typically the product that we would produce as part of our earthwork analysis. So getting into some examples, this may be a little more rural, but I think it paints a picture. So if we're developing a new subdivision with some fairly challenging topography, we're getting into it a few clicks away, and basically we have a road, we have a hill, and we're trying to do a single-family residence. This is that cross section. You basically have a couple different ways you can do it. You can have a big hill on the right, you can have a wall on the right, you can terrace it, you can have a wall at each end. Which one is better is the question we get a lot, or which one do we want to do? There's a lot of factors that would come into play with that. Some of it is how valuable the land is. Do we want to pay for these extra walls to have more usable space, or are we okay with using 3-to-1 slopes to both ends and saving some money? So I guess the point is there isn't really a better answer. You know, if I was living here, I don't know about you guys, I would probably want this one, so I could just walk straight in from my car, not have to climb some stairs. But it really depends on the product and how much effort and engineering we really want to put into the earthwork analysis. Here's another sort of example about how grading and just the site and the existing conditions will affect you as the architect. You may look at this site and be like, man, I have a pretty big site. We can do a lot here. But then you start looking at the grading, you start looking at easements, you start looking at wetlands, rivers, streams, and all of a sudden your site's pretty much carved up of what you're not allowed to touch, what you have to tie into, and what you're able to adjust the grade so that you have a nice flat spot for your buildings. And feel free to chime up any questions if you guys see anything that piques your interest. So a lot of times we'll be given like sort of a preliminary site plan or a bridging documents where they sort of have things sort of figured out, and we'll take it to the next level of doing fine grading, working with the architect to set the FFEs. And basically in the condition on the left, everything was sort of on the same plane, and we're able to look at it a little closer, do that earthwork analysis. It definitely changes the visual of it because we're stepping things, but generally speaking, we're able to try to reduce the cut, reduce the fill, so that we don't have to haul stuff offsite. Another factor that could play into this is maybe you have a neighboring property where you need that fill. So it depends on if it's a multi-phase project or if it's just a single site where you don't want to haul anything off and don't haul anything on. That sort of brings it to the end of where grading is. And with the 3D modeling that we're doing in Civil 3D, the question we always get is, how do we get our Civil 3D model into Revit? You know, Revit and Civil 3D are both owned by Autodesk, but unfortunately they don't communicate as well as they could. One of the ways that we're sort of working around that is we're using some softwares, including InfraWorks. What you're looking at here is InfraWorks. Navisworks is a little more better for detailed coordination, but the visualization of InfraWorks is really good. We can bring in our 3D surface, our pipe network. We can bring in the MEP pipe network, and we can bring in your Revit model. and look at how it all lines up, check for conflicts. This is sort of an example where, like, in plan view, it might look good, but then you start looking at the 3D engineering view, and you're really able to see quickly how things might work or might need some more work to get to the finish line. Another sort of visualization in 3D networks is we can, there's software out there, beta software, where you could take the 3D models and with some augmented reality, go out to the construction site if you're walking with the client and try to explain to them how the pipe network will look in the future overlaid on your site. We don't have it turned on, but you could theoretically also have your Revit model turned on to see a rendering of the facade in the background.
This would be a field tablet that you would use. So you would hold up the tablet,
yeah,
and you can actually see the existing background through your tablet, and the tablet will overlay the digital utility models, the Revit buildings, everything, while you're actually standing there.
And I'm sure you know, but there's also situations where you can put on the VR goggles. I would not recommend walking around an active construction site with VR goggles and stuff. But yeah, this is, I mean, I actually took these pictures. It's pretty cool to sort of see that next step. Not quite there if you start moving around too quick, but certainly has some growth as we coordinate more with our 3D models. And lastly, the biggest thing for us is, like, when we start a project, to explain what our, what our grading coordinate system is. What datum are we in? What datum are you assuming? Are you assuming 0, 0 is the southeast corner of the building and you're rotating it so it runs east-west? How do we get back and forth between these two so that when you request our surface, it pops right in? One of the main ways we do that is we can use a shared coordinate system, or as long as we sort of set it up with a BIM coordinator at the beginning of the project, it works well. If you've ever seen a project not work well, a lot of times it's because the coordination between the civil, the MEP, and the architect in the digital world aren't lining up, especially when we're jumping between units and coordinate systems. Do you guys mainly work in Rhino or Revit, or what? Revit, yeah. Yes.
Does it support the Revesto? You know Revesto?
No, not
That's
for
that one, yeah.
But yeah, so basically, this is also rendering from InfraWorks. But basically, between InfraWorks and Navisworks, we're basically able to export the civil 3D surface, some of our civil 3D pipe networks, and then import pretty easily the Revit model from the architect and the MEP and see how things are lining up, and also build some pretty cool visualizations for presentations and coordination. I think some people would like to one day be able to, like, plug this into to some construction equipment and build from this, but I think we'll be doing construction plans for a while longer. And that's it from us. Do you guys have any more questions?
As far as the blending of the two, we do have some cool little tricks we can do to get this civil 3D grading into Revit that we've worked with other architecture firms. I know Rhino comes into play, and there's some other software out there where we can blend it. It's just not an exact, you're not getting the accuracy that we see in civil 3D. But from a render and presentation perspective, there are tools. Well, if there's no more questions, we'll hang out for a few more minutes. Feel free to stop by, say hi. The sign-in sheets are in the back, so if you need credit, please sign up. We have some cards back to food, so please eat up, and thank you again for having us.
Thank you.
Appreciate it.